Time. It's one of those things that everyone experiences, yet few truly understand. We live our lives around it, checking the clock, counting the days, and marking milestones. But when you really stop to think about what time actually is, it becomes apparent that we don't know much at all. It's a paradox that has intrigued not just scientists, but philosophers, writers, and dreamers for centuries. Time is constantly present in our lives, moving us forward in an endless stream, but is it really that simple? What if time isn't as fixed as we believe? Could it be something far more elusive, flexible, and complex? Could time be not just something that measures change, but also something that can be manipulated, bent, or even traveled through? These are the kinds of questions that have baffled humanity for as long as we've been aware of time's passing. The idea that we could alter the past or glimpse the future is often brushed aside as pure science fiction, but is it really? Could time be more than just an abstract concept, something that we are bound to within the constraints of our own experiences? Modern science, particularly physics, has revealed that time is far stranger and more mysterious than we ever imagined. While time may seem like a constant and immutable force, it's actually something that bends and warps, influenced by the speed at which we move and the strength of gravity in our surroundings. In fact, time doesn't behave the same everywhere. What we once thought of as a solid, linear progression, a simple flow from the past through the present and into the future, is now understood to be far more malleable. Albert Einstein's theories, particularly his theory of relativity, introduced a mind-boggling perspective on time. According to Einstein, time isn't absolute. It isn't the same for everyone, no matter where they are or what they're doing. Time, in Einstein's view, is relative. It changes based on your speed and the gravitational field you're in. This means that time moves differently depending on your position in space, and your motion through it. Imagine that time could stretch and shrink depending on how fast you're moving or how close you are to a massive object like a planet. This idea is called time dilation, and it's one of the most fascinating and mind-bending consequences of Einstein's theory. The concept of time dilation shows that time doesn't flow at a fixed rate for everyone. It's a reality that has been confirmed time and again through experiments, from flying precise clocks in airplanes to sending satellites into orbit. The faster you move, the slower time seems to pass for you. So, if you were able to travel close to the speed of light, time for you would stretch out like an elastic band, making it possible for you to experience only a few minutes or hours, while years or even centuries could pass on Earth. Time, in a sense, becomes something you can stretch or compress, something that is not constant but flexible, dependent on your relative motion in the universe. Take a moment to imagine the possibilities. What if we could harness this ability to manipulate time? Could it make time travel into the future possible? Or could it open doors to the past? While time travel may sound like a concept out of a science fiction novel, it's something that physicists have started to seriously explore, especially when it comes to the incredible effects of gravity and speed on time. But even within the framework of Einstein's relativity, there are still mysteries. Could time be manipulated even further, beyond the relative effects of speed and gravity? Time is more than just a physical concept, it's a dimension in itself. We experience time as a constant force that flows in one direction, but in Einstein's theory of relativity, time is deeply connected to the fabric of space itself. Time and space are bound together in what we call space-time, an interconnected four-dimensional system that underpins everything in the universe. It's not just a matter of understanding how objects move through space, it's also about how time is influenced by those movements. The speed of light is the only constant in this framework, the one universal speed that governs how everything moves through space-time. And it's the relationship between time and space that gives us the idea of time dilation. The famous thought experiment known as the twin paradox perfectly illustrates the bizarre nature of time in the context of relativity. Imagine two identical twins. One stays on Earth while the other goes on a journey through space, traveling at close to the speed of light. When the traveling twin returns, they find that they have aged only a few years, while their twin on Earth has aged much more, perhaps by decades. This seemingly paradoxical outcome occurs because time passes differently for objects moving at different speeds. The traveling twin has been moving at relativistic speeds, so for them, time has slowed down, meaning they have aged much less than their twin, who stayed stationary on Earth. The twin paradox challenges our intuitions about time and highlights just how different time can behave depending on the observer's relative motion. But time's strange behavior doesn't stop with speed. Einstein's general theory of relativity takes into account the effects of gravity, and it's here that things really start to get wild. Gravity isn't just a force that pulls objects toward one another, it also bends the fabric of space-time itself. Massive objects like planets and stars create distortions in space-time, causing time to move more slowly the closer you are to these massive bodies. For example, if you were to stand near the surface of a massive planet, time would pass more slowly for you compared to someone far away from that planet, where gravity is weaker. This effect, called gravitational time dilation, has been confirmed by experiments involving clocks on satellites and on the ground. It's a crucial consideration in technologies like GPS, where time dilation must be factored in to ensure that our systems are accurate. This is where time starts to seem even more elusive. Time isn't just something that moves forward at a steady pace, it's influenced by the very structure of the universe. The stronger the gravity, the slower time moves. Similarly, the faster you travel through space, the more time stretches out for you. So, time doesn't exist independently of space and matter, it's woven into the very fabric of the cosmos, constantly shifting and changing depending on where you are and what you're doing. This realization opens up all kinds of possibilities, including the theoretical idea of time travel. The concept of time travel has captured the imagination of countless people for centuries. What if we could jump into a time machine and travel to the past or the future? Could we change the course of history or witness future events unfold before our eyes? While time travel is still very much in the realm of science fiction, it's also a topic that's been taken seriously by physicists. Einstein's general theory of relativity suggests that time travel to the future might be possible, but traveling back in time is a much more complicated and controversial idea. According to some interpretations of relativity, certain solutions to Einstein's equations suggest the possibility of wormholes, tunnels in space-time that could, in theory, allow for travel to different points in time. However, wormholes are highly speculative, and we currently have no evidence that they exist. More importantly, they pose some serious paradoxes that challenge our understanding of causality and logic. One of the most famous paradoxes associated with time travel is the grandfather paradox. Imagine you could travel back in time and prevent your grandfather from meeting your grandmother, effectively preventing your own birth. If you were never born, how could you have traveled back in time in the first place? This creates a logical contradiction, and it's one of the greatest challenges in the theory of time travel. Some physicists propose that the solution to this paradox might lie in the idea of parallel universes or alternate timelines. Perhaps, by changing the past, you would create a new timeline in which you were never born, but your original timeline would still exist, and you would still have traveled back in time from that alternate universe. Other paradoxes that arise from time travel include the bootstrap paradox and the predestination paradox. The bootstrap paradox occurs when an object or piece of information appears to exist without any clear origin. For example, imagine you travel to the past and give a book to a young author who then publishes it. The book then ends up in your hands, and you bring it back to the past, where the cycle repeats. But where did the book originally come from? The predestination paradox is similar, but it's about the chain of events that leads to time travel in the first place. If your actions in the past inevitably lead to you traveling to the past in the first place, how can you ever break out of that loop? These paradoxes raise serious questions about the nature of causality and whether time travel is even logically possible. But perhaps the most intriguing paradox of all is the altered past paradox, which deals with the butterfly effect. What happens if you go back in time and change something, no matter how small? How does that affect the present? Could even the slightest change in the past create massive, unpredictable changes in the future? This idea has been popularized in science fiction, where even small actions, like stepping on a bug or making a seemingly insignificant decision, can have enormous consequences for the future. In the context of time travel, the altered past paradox raises questions about causality and whether our universe is truly deterministic. If we can change the past, does that mean we can change the future as well? These paradoxes, though fascinating, highlight the incredible complexities and contradictions that arise when we try to apply the concept of time travel to the real world. While the laws of physics allow for the theoretical possibility of time travel, especially in the form of traveling into the future or even exploring wormholes, the logical and causal issues that arise from traveling to the past present serious challenges. Are we stuck in a universe where time is fixed and irreversible, or could the boundaries of time be more flexible than we ever imagined? We may never have definitive answers to these questions, but the pursuit of understanding time continues to push the boundaries of science and human imagination. Time is one of the greatest mysteries of the universe, and as our understanding of space, gravity, and the quantum world deepens, we may one day unlock the secrets of time and its true nature. Until then, time remains an enigmatic force, shaping the universe and our lives in ways we have only begun to understand. It's a force that not only influences our perception of reality but also challenges the very foundation of what we know about the universe itself. Time may indeed be an illusion, but it's an illusion that governs everything we do, and perhaps that is its greatest mystery.